Hello everyone! Welcome to Aquatic Maths. This is Pranjal and today we will do Chapter 1 Rational Number of Class 9 Part 2. Okay. First of all, let us recall a thing. Okay? Then we will move to the next part. See the question, I have a question for you, that the maximum number of integers between two consecutive natural numbers is. There are two consecutive natural numbers, means one after the other. How many maximum number of integers can be there between two consecutive natural numbers? We all know that the natural numbers are 1, 2, 3 up to so on, and integers are negative numbers, 0 and positive numbers. Also we know that every integer is not a natural number, and one more thing, we know that in natural numbers there cannot be any integer, right? So the answer of this question is the maximum number of integers between two consecutive natural numbers is 0. Okay. So let's now move to the new topic. We are gonna discuss how to convert the rational numbers into decimal expansion. Okay, this is a very easy topic. You had already learnt about this. How can we convert any rational number? Rational number is a kind of a fraction. Now you know that how to convert the fractions into decimal expansion. It is the same thing. In similar manner, we can convert the rational numbers into decimal expansions. As we have 35 upon 60, we know about long division method, right? Now, according to the long division method, we just have to divide the numerator by denominator. Here, see the first example, 35 upon 60. In this also, we have to just divide 35 by 16. Now when we divide 35 by 16 on 2, we get 32. So when we subtract it, we will get 3. We will take the carryover as 0. It becomes 30 and we will put the decimal point here, and on 1 we will get 16. 30 minus 16 is 14. Now we will again take the carryover as 0. Now on 8 we can write 128 here. Now 140 minus 128 is 12 only. Again we will take the carryover as 0. Now it is on 7, it is 112. When we subtract 112 from 120, we will get 8. Again we will take the carryover as 0, and on 5 we will get 80, and 80 minus 80 is 0 only. So from here we can see that when we divide 35 by 16, we will get the answer as 2.1875. So it is the decimal expansion of the rational number 35 upon 16. Clear? Now the next one, this is very simple thing. Whenever we have to convert the rational number into decimal expansion, we just have to divide the numerator by the denominator. Okay? Now see the next part. Now we have 10 upon 3. 10 upon 3 means we have to divide 10 by 3. Now we know the table of 3. On 3 we get 9. When we subtract 9 from 10, we again get 1. We will take the carryover 0. So it becomes 10, and here we have to put decimal. Now on 3, we again get 9. 10 minus 9 is again 1. Again we will take the carryover as 0. Again on 3, we get 9. So we have to write 3 here again. Again we will get 1. In the similar manner, we have to continue it and up to infinite times, and we always get the remainder as 1. Okay, so from here we get to see that 10 upon 3 is equals to 3.333 up to so on. It will continue up to infinite times. Okay. Now see the next one, 5 upon 8. I hope it is clear to all of you. You all know how to divide, how to do the long division. You just have to do the long division and hence you will get the decimal expansion of the rational numbers. There you can see the 4 questions are given: 5 upon 8, 9 upon 13, 5 upon 11 and 22 upon 7. Just give it a try, find it out. If you find any problem, give me comment. I will see the comment and I will help you out. Okay. So now after that, now the next topic is decimal expansion of rational numbers. Decimal expansion, you had already learnt about decimal expansion. What is the meaning of decimal expansion? We know how to convert the rational numbers into their decimal expansions. Now there are two types of decimal expansions. First one is terminating decimal expansion and second is non-terminating repeating decimal expansion, or you can also name it as non-terminating recurring decimal expansion. Now what does these two terms means? Terminating decimal expansion means we have a rational number. We know how to convert a rational number into the decimal expansion. When we are converting the rational number and we get the remainder as 0, then that decimal expansion is the terminating decimal expansion, means it stops after a certain point. Any decimal expansion that stops after a certain point is terminating. For example, we have 1 upon 2. 1 upon 2 is 0.5. We will get 0 as the remainder when we divide 1 by 2. So it stops after 5. It means it is the terminating decimal expansion. Okay. Also, we just solved a rational number 35 upon 16. 35 upon 16 was 2.1875 and we had just seen that the remainder become 0, right? So it is the terminating decimal expansion. Now the next one we have is non-terminating repeating decimal expansion. Non-terminating means that decimal expansion which never stops. It will continue up to infinite times. And repeating means the decimal expansion which is following any pattern. For example, we just learned 10 upon 3 and we get that it is 3.333 up to so on. It is non-terminating, means is continued, and it is following a pattern. 3 is repeating every time. It means it is recurring. It means we can say that it is non-terminating repeating decimal expansion, or another term, non-terminating recurring decimal expansion. Okay. Now the next thing is, how can we convert the decimal numbers into p by q form? We just learned now how to convert the rational numbers into decimal expansion. That we can do by the long division method. Now we have to learn how to convert the decimal numbers into p by q form, that is rational numbers. Now we just saw that there are two types of decimal expansions of rational numbers. So first one were terminating numbers. First we will learn how to convert the terminating numbers, terminating rational numbers, terminating decimal numbers into the rational numbers. See, the first example is 3.142678. Now, to convert this into rational number, you just have to write the number as it is without the decimal, 3142678, and after that it will be the numerator, and now you have to write the denominator. How can you write the denominator? Just write 1, and after that you have to put the number of zeros equal to the number of the digits that are after the decimal given in the question. Okay, as we can see that there are 6 digits after the decimal, so we have to put 6 zeros here. So this is the P by Q form, and P by Q form where P and Q both are integers and Q is also not equal to 0, so we can say that it is the rational number that we get after converting the given decimal number. Okay, in the similar manner, if you see the second one, 4.28579, just write the number without decimal point, 428,579. After that you have to write the denominator, just write 1 and put the number of zeros equal to the decimal equal to the digits that are after the decimal point. Here we have 5 digits, so we have to put 5 zeros, 1 2 3 4 and 5. It is also the P by Q form. P by Q form means the rational number form where P and Q both are integers and Q is not equal to 0. Hence we got to know how to convert the terminating numbers into the rational numbers. Okay. Now we will discuss how to convert the non-terminating numbers into the rational numbers. Now non-terminating numbers are non-terminating repeating numbers. Now non-terminating repeating means those which are continued. Also repeating means which are following any pattern. See, here we have 0.333 up to so on, right? Now here it is given that it is equals to 0.3 bar. Why we are writing it as this? Here the number 3 is following a pattern. Every time we are getting 3 which is same every time, and it is continued up to infinite. So we are writing 0.3 and we are putting bar on 3. Okay, now we have to convert this non-terminating repeating number in the form of P by Q. How can we convert it? Let us take this number as x. Let x is equals to 0.3 bar. Okay, now give it the name as equation number 1. Now next step, you have to multiply the first equation by a number. By what number you have to multiply? Just see the digits on which there is a bar. As there is a bar on one digit only, so you have to multiply equation 1 by 10 only. Multiplying 1 by 10. Now when you multiply 1 by 10, you will get 10x is equals to 10 multiply 0.3 bar, right? Now see, 0.3 bar was 0.333 up to so on, right? This thing. Now from here you can write 10x as it is, and it is equals to, when you multiply 0.333 up to so on by 10, you will get 3.333 up to so on. 3.333 up to so on is equals to 3.3 bar. We can write it as this now. So it is 3.3 bar. Now give it name as equation number 2. Now the next step is just subtract equation 1 from 2, means 2 minus 1. When we subtract equation 1 from 2, we will get 10x minus x equals to 3.3 bar minus 0.3 bar, right? Now 10x minus x is 9x, and 3.3 bar minus 0.3 bar is 3 only. Now it is a linear equation in one variable, and we already know how to find the value of x from here. From here we will get x is equals to 3 by 9. 3 and 9 both can get cancelled out at 3 only, so it is 1 and it is 3, so x is equals to 1 upon 3. Now see, 1 upon 3 is the p by q form, where p and q both are integers and q is not equal to 0. Hence, we can say that the non-terminating repeating number, that was 0.3 bar, we can write it in the form of p by q, that is a rational number, which is 1 by 3. Clear? Okay. Now, let us discuss some more examples. Next is x is equals to 1.27 bar. Here you can see that 27 has bar on it, means there are 2 digits which have bar. It is also a non-terminating repeating number, that's why we can use bar on it. Now let us first give this equation as equation number 1, right? X is equals to 1.27 bar. Now the first step we have to do is, we just have to multiply the given equation by any number. Now here there are 2 digits which have bar on it, so we have to multiply that number by 100. So first step is multiplying 1 by 100. When we multiply 1 by 100, we have to multiply both the sides, left hand side as well as right hand side. So when we multiply left hand side, we will get 100x equals to 100 multiply 1.27 bar, right? Now listen carefully and see carefully also. On the left hand side there is 100x. We are writing 100x as it is. Now see the right side. On right side, what is given to us is 100 multiply 1.27 bar. Now see, I am writing 100 as it is, multiply. Can I write 1.27 as 1.2727 up to so on? If I can write it as this, then you know that as we have to multiply it by 100, it means this decimal will move up after 2 points, right? So it is equals to 127.27 up to so on, right? Up to so on means 27 is repeating. It means it is equals to 127.27 bar, right? This is the answer of the right hand side. So 100 multiply 1.27 bar is 127.27 bar, means 127.27 bar. This is equation number 2. Now the next step, you just have to subtract equation number 1 from equation number 2. Directly write 2 minus 1. 2 minus 1 means 100x minus x equal 127.27 bar minus 1.27 bar, right? It is 99x equals to, when you subtract 127.27 bar and 1.27 bar, you will get 126, and x is equals to 126 upon 99. Both these numbers can get cancelled out at 3. When we cancel it out at 3, it is 42 and it is 33. Again on 3 it is 14 and it is 11. So from here x is equals to 14 upon 11. This is the p by q form, where p and q both are integers, 14 and 11 both are integers, and denominator is 11, means not equals to 0. So it is a rational number, means the decimal expansion, that was non-terminating repeating 1.27 bar, we can write it in the form of rational number as 14 upon 11. Clear? Now see the next one. X is equals to 0.235235 up to so on. Means 235 is repeating, means we can put bar on 235, right? Here x is equals to 0.235. We are naming it as equation number 1. Now I had already told you that what you have to do in the first step. You just have to multiply it with some number. Now see, here the bar is on 3 digits. So you have to multiply equation number 1 by 1000. Because I told you, just put 1 and put the equal number of zeros as the digits which have bar on it. Okay. So here you have to multiply the equation 1 by 1000. Write down multiplying 1 by 1000. Now we have to multiply both the sides, left hand side as well as right hand side. So it is 1000x equals to 1000 multiplied by 0.235 bar. Right? Now left hand side as it is, 1000x equal, when we multiply 1000 by 0.235 bar, we have to shift decimal after 3 digits. Means when we see this thing, we have to shift digits after 5, decimal after 5. Means it will become 235.235 bar. Name it as equation number 2. Now the next step, we just have to subtract equation number 1 from equation number 2. Means equation 2 minus equation 1. It is 1000x minus x equals 235.235 bar minus 0.235 bar. Now it is 999x equal to 235. Right? Now x is equals to 235 upon 999. Clear? This is the P by Q form, means it is the rational form of the given decimal expansion. Clear? Now see the next question. X is equals to 0.47 bar and the bar is on 7 only and not on 47. It is on 7 only one digit. Now see, first of all we just have to name it as equation number 1. Now next step, we have to multiply it with any number. Now I told you, you have to multiply it with that number. You just have to put 1 and you have to put the number of zeros as the numbers which have bar on it. And in this question we have bar on 7 only, means on one digit only. It means we have to multiply this equation by 10 only. Okay, just multiply equation number 1 by 10. When we multiply it by 10, we will get 10x equals to 10 multiplies 0.47 bar. Now see, left hand side as it is 10x equals to. Now see the right side. We have to multiply 0.47 bar by 10. It is 10 multiplies 0.477 up to so on. Right? Now when we multiply by 10, we have to shift decimal point after one digit only. So it will become 4.777 up to so on. Right? Now we can write it as 4.77 bar. Can I write it as this? It is equation number 2. Now we have to subtract equation number 1 from equation number 2. When we subtract, we will get 10x minus x equal 4.77 bar minus 0.47 bar. Now 10x minus x is 9x only, and it is 4.3, right? Now x is equals to 4.3 upon 9. Also we can write it as 43 upon 90. This is the rational form, means p by q form, where 43 and 90 both are integers, and denominator is 90, so it is not equal to 0, so it is the rational form of given decimal expansion 0.47 bar. So it was all for today. I hope you liked the session. If you like, then please subscribe the channel and press the bell icon. Give the likes and comments as much as possible. Thank you so much. Bye bye everyone.